Hello, I am Serge Salat, architect and urban designer, president of the Urban Morphology and Complex Systems Institute, and author of the Integrated Guideline on Sustainable Neighborhood Design. In this unit 121, Designing with Bioclimatic Principles and Green and Nature-Based Solutions, I will explain you the bioclimatic strategies which make the urban fabric of the sustainable neighborhood particularly efficient, and the green and nature-based solutions which can create an efficient eco-cycle in the neighborhood. We rely on nature and the power of healthy ecosystems to protect people, optimize infrastructure, and safeguard a stable and biodiverse future. Redesigning public space with nature-based solutions and climate-responsive urban fabrics improves the environmental performance and resilience of neighborhoods, particularly for the urban poor, and as a city-scale positive impact. This overview presents design strategies at neighborhood level that contribute to SDG 3, 5, 11, and 13. This overview provides tools to leverage and integrate nature-based solutions within neighborhoods. It shows how to deploy bioclimatic design strategies for the urban fabric in different climatic zones. Introduction: Nature-based solutions and bioclimatic design. What are nature-based solutions and bioclimatic strategies? Nature-based solutions shown here in Singapore leverage healthy and well-managed ecosystems. They provide essential benefits and services to people. These include reducing greenhouse gas emissions, securing safe water resources, making air safer to breathe, and providing increased food security. Urban bioclimatic design adapts layouts of buildings, green spaces, squares, and streets to local climates, optimizing natural lighting and shading, natural ventilation and cooling in summer, solar gains in winter, and solar energy collection for photovoltaics. Integrating nature-based solutions in the urban fabric can be done at all scales, as shown here in Hangzhou. It has many advantages. Nature-based solutions meet climate adaptation and mitigation goals. They help biodiversity to thrive and human settlements to become more resilient. Incorporating nature in cities improves their livability, particularly for vulnerable populations, by reducing temperatures, filtering water, and cleaning the air. Bioclimatic design strategies should be tailored to the climatic context. In China, for example, traditional courtyards are modulated according to the latitudes and climates. In the dry, colder areas of North and Northwestern China, open spaces are generous portions of the house, courtyard complex, while the walls block cold winter winds, and the south orientation increases the solar gains. Throughout central China, where winters are mild and summers hot, transitional spaces such as verandas increase in extent. In hot and humid areas of southeastern China, open spaces shrink in size, while transitional gray spaces increase. Special attention is paid to natural ventilation and to blocking sunlight from penetrating the urban texture. Part 1 will present integrating nature-based solutions in neighborhoods. Integrating nature-based solutions in neighborhoods can be done at many scales. These include creating ecological corridors, greening the urban fabric by weaving buildings and green spaces, designing green blocks, and working with the natural water cycle, as shown here in a project by Wuha Architects in Dhaka, Bangladesh. Creating ecological corridors. Ecological corridors are networks of interconnected nature-based solutions interventions across urban and peri-urban landscapes. They support ecosystem functions to provide benefits for people and nature. They involve a continuous process of collaborative, integrated and transformative design, planning and implementation at landscape scale to build resilience, as shown here in a project in Singapore. Greening the urban fabric at microscale, as shown here along the Manhattan High Line in New York, is a key action. The urban fabric is the physical texture of an urban area, comprising streets, squares, buildings, and their relationships. Greening the urban fabric encourages biodiversity, reduces the urban heat island effect, provides shade and cooling, improves air quality, and reconnects people with nature. Greening the urban block. In hot and humid climates, layering, hollowing, and greening urban blocks in 3 dimensions has the potential to recreate street life and community space, as shown here in Kampung and Miralty in Singapore. These open-air precincts offer new street levels as part of a 3-dimensional matrix. Blocks with a 3D microurbanism allow integrating solar energy, urban agriculture, commercial and recreational space, and housing in stacked structures. 3-dimensional greening allows reaching a green plot ratio above 100%. This mitigates the urban heat island effect, saves cooling energy, and provides shading for communal spaces. Working with the nature water cycle. For water, replacing engineered infrastructure by solutions that work with nature, in which water recycles and supports life at local scale, provides many benefits, as shown here in Hammarby Sjöstad. It softens the built environment, it naturally absorbs storm water and diverts it from the sewers and wastewater treatment plants. It improves overheated building environments as water acts as a cool sink, enhancing wind circulation patterns. Part 2. Bioclimatic strategies in cold climates. In cold climates, goals are to warm the microclimate and retain heat gain, to design outdoor spaces to be comfortable, to promote sustainable green density, to manage water as a sustainable amenity. Strategies minimize wind flow and maximize winter sun. Buildings retain heat and match weather. Breaking up outdoor spaces with comfort stations. Designing for winter programming and extending microclimate consideration to aesthetic enhance outdoor space experience. In winter months, wind can make cold climates feel 10 to 20 degrees colder than they really are. For people to feel comfortable outside, they have to be protected from cold winter winds. Cities can provide that protection with street patterns, as shown here in Edmonton, and structures that break up and block the wind, as shown here in Kalasatama in Finland. Blocking wind can be achieved by using trees as natural wind barriers or buffers by planting them near windows to block cold air from entering the buildings, designing a slightly distorted street grid, and designing streets with an orientation away from the prevailing winds shelter constructions from the wind. This is shown here in Perkins plus Will Chaudière Island project. Gradual height transitions, allowing the cold wind to pass over the top of buildings, reduce the impact of winter winds. Planning for sun access ameliorates cold climates outdoor spaces. Strategies include orientating buildings to the south for maximum winter sun penetration and protecting access to winter sun in public spaces. In Toronto, for instance, Perkins plus Will analyzed the site's winter sun patterns to shape the urban form of the new development to maximize winter sun exposure. Like the work they did in Toronto, Perkins plus Will surveyed Chaudière Island and identified several plazas that were to receive the winter sun before turning to the design phase. Breaking up outdoor space with comfort stations by providing a small protected destination every 5 minutes helps break up the cold wind and encourage individuals to use public spaces in the winter. In the Outer Harbour project area by Parkins-Swale, for instance, the planners provided a visual of physical destination every minute, like benches, public art and other landscape elements. Every 5 minutes they designed comfort stations with heaters and restrooms. Microclimate considerations lead to pleasant, people-centered, unique and beautiful places. In Malmö B001 in Sweden, for example, taller white buildings define the edges of the scheme and break the cold winds, while smaller, light-colored buildings and small open spaces in the interior create human scale. Ever-changing building direction and arrangement avoid winds to channel along streets and create a dynamic character, full of unexpected spaces and views within a walkable environment. The diverse and beautiful design responds both to the environmental context and to human needs. Part 3. Bioclimatic strategies in hot and dry climates. In hot and arid climates, extreme heat may result in stressful street-level conditions to the extent that it has a negative impact on the development of a pedestrian-friendly environment. Acceptable levels of outside thermal comfort can be achieved through an integrated approach. That includes streets and buildings proportions, architectural and natural shading, air movement and open space, urban forestry and the use of water, building design, and finally materials characteristics, including thermal inertia and reflectivity. Goals in hot and arid climates include preventing urban heat island in summer, designing outdoor space to be comfortable, and integrate nature-based solutions. Bioclimatic strategies include optimizing street proportions to create shade during the day and release heat at night, designing thin buildings for cross-ventilation, building with cold materials to reflect radiant energy out of surfaces, building with high thermal inertia materials to maintain inner spaces cooler than outside during the day. Strategies for public spaces are enhancing airflow with a rough urban texture, accelerating wind movement. Networks of green and blue spaces cool the urban fabric, enhance pedestrian comfort, and are an aesthetic amenity. Traditional courtyard forms. Continuous courtyard textures bring several advantages for hot, arid climates. These include greater envelope surface area and thermal mass, greater access to daylight thanks to the courtyard and shallow plants, greater shade and enhanced thermal comfort during hot days. Courtyard houses release heat during cold nights because of their thermal inertia and limit the need for air conditioning. This drawing shows how the integration of strategies shapes the urban fabric in hot and arid climates. The urban texture's roughness is increased by irregularity and by diagonal towers, accelerating wind flows. Green and blue corridors through blocks, openings, let major and minor breezes go through. Streets are narrow and tall to shade buildings. Green and blue feathers cool the urban fabric. Cold materials reflect the heat out of the urban fabric. Buildings are designed with vertical and cross ventilation. Shading with walls, covered walkways, and trees protects people from the sun. Simulations show that a street canyon proportion of 2:1 balances thermal comfort and urban heat island, providing a cooler pedestrian environment during the day while permitting an acceptable amount of heat release during evening hours. In hot and arid climates, night temperatures are significantly lower than day temperatures. Narrow and tall streets, like those of Casablanca traditional urban textures, avoid heat penetration daytime and allow heat to radiate to the cold sky at nighttime. Buildings shade each other to reduce the facade surface temperatures. Streets and sidewalks are shaded in summer, thus improving comfort for pedestrians. The connected oases consist in distributing a network of open green and blue spaces with major corridors and cool pockets within blocks as shown in the drawing. In Sidi Bou Said, Tunisia, narrow streets are naturally shaded by large overhanging trees. Increased turbulence and vertical flows are produced when the wind is permitted to flow through open channels rather than by removing significant portions of the street wall volume. By locating diagonally placed towers at the corners of the block, these strategies create discontinuities in the urban block, favoring passages for wind movement. Buildings designed with adequate cross and vertical ventilation can remove heat and cool down the interior mass, reducing the need for mechanical cooling during the day. Cold materials have a high reflectivity factor to short-wave radiation, direct sunlight, and their ability to release heat into the environment during the evening hours. They are shown here in the shaded streets of Sidi Bou Said in Tunisia. Hot and arid climates present a great thermal amplitude. The diurnal thermal range can be as much as 22 degrees Celsius. Massive walls with high thermal inertia help damping those variations. They allow the heat to be transmitted with a roughly 12-hour delay, so the structure slowly conducts heat during the day and the cold nights. At sunrise, the structure is cool and has achieved thermal equilibrium. Then it heats slowly during the whole day, providing cool interior temperatures for the inhabitants. The master plan proposed by GAL for the Malawi Souk of Life in Oman integrates all these strategies. It is based on a quality public realm protected by compact city walls as unifier of the entire neighborhood. The protective city walls optimize climate and urban infrastructure. The build structure and the height of buildings create a cooler microclimate. Lower buildings towards the west make it possible to catch cold winds coming from southwest, while higher buildings with narrow passages block from warm northeast winds. Moreover, the shaded colonnade around the park creates a comfortable environment for pedestrians, and the fallage, an age-old watering device, cools the sites and form an attraction for people. Narrow pedestrian passages cut through the built fabric provide intimate and comfortable walking routes leading from the site perimeter to the park. They are shaded thanks to a height aspect ratio and low sky view factor. These funnel-shaped alleys offer a sequence of views and small plazas. Part 4. Bioclimatic strategies in hot and humid climates. Goals in hot and humid climates are cooling the microclimate, mitigating the heat island effect, and designing outdoor spaces to be comfortable. Strategies are to maximize wind flows and minimize solar radiation, to cool with vegetation and with water, to maximize shading in outdoor space, and to integrate green and blue infrastructure. The drawing shows how the integration of strategies shapes the urban fabric. Buildings are porous with ample openings to create a breathing urban fabric, allowing light and air to penetrate with nature-based solutions to cool naturally. Good ventilation removes excess heat from streets and open spaces and provides cross ventilation in buildings. Major and minor breezeways and orientating breezy streets to the prevailing wind maximizes air movement and cross ventilation inside and outside buildings. Linking open spaces into ventilation corridors allows the prevailing winds to penetrate the city fabric. Wind flows can be enhanced by creating building separations. High variation between building heights accelerates wind flows when taller buildings are 2 times higher than lower buildings. Reducing building frontage enhances wind penetration. Creating voids between and in buildings with gaps and sky gardens increases permeability. Shading lowers the sun exposure and minimizes solar heat gains through the facades. Orientation and good distribution of buildings can provide shade on nearby outdoor structures and spaces. Layering and hollowing urban blocks recreates street life and community space with gardens and parks in the sky, becoming naturally ventilated clusters of occupation. Deciduous climbing plants canopies act as dynamic solar shading devices, responsive to the seasonal climatic change and enhance biodiversity. Water acts as a natural cooling device. Open spaces along the seashore contribute to cooling. At night, the cool sea breezes ventilate hot air trapped in the city fabric. Low-rise permeable urban blocks allow the sea and perpendicular wind corridors enhance wind flows. Preserving wetlands contributes to flood control, carbon sink, and shoreline stability. Water catchment areas, ponds on roofs, ground floor, and evaporative cooling systems cool the ambient temperature. Conclusion, lessons learned. Key takeaways are: nature-based solutions should integrate the needs of all users from the initial planning and design phase. Adapting nature-based solutions and bioclimatic strategies to the local cultures and climatic conditions has multiple benefits. Bioclimatic strategies in cold climates plan compact settlements with shape and orientation to maximize sun access and minimize wind flow penetration. Bioclimatic strategies in hot and dry climates rely on narrow and tall streets and courtyard forms with clear colors to prevent solar radiation to enter inside the urban fabric and reflect it. In hot and humid climates, a breathing fabric facilitates airflow, shading minimizes solar gains, while greening, water, and nature-based solutions cool naturally the neighborhood.